Ever hit that translate button and think, how does this thing work so well?
Yeah, it's pretty mind-blowing.
Well, we're going deep on the paper that changed the game.
Oh, for sure.
Attention is all you need.
A classic.
It brought us the transformer, and it's
Mhm.
had a massive impact on how machines deal with language.
Like even stuff you probably use every single day.
Absolutely.
Yeah.
So before we get into the nuts and bolts, can you give us the quick rundown? What was language processing like before the transformer?
Yeah, so think back, a few years.
Okay.
We were heavily into recurrent neural networks, RNNs, for things like translation.
Right.
Imagine, like, reading a sentence, but you have to go word by word,
Oh, wow.
trying to hold the entire meaning in your head until you get to the very end.
That sounds rough.
It's slow, information gets lost, especially with longer sentences.
It's like trying to remember a 20-item grocery list. So how did the transformer fix this?
It's all about attention mechanism.
Attention mechanism.
Okay. It's like skimming a news article,
Right.
Your eyes just naturally go to the important words, the phrases that tell you the main point.
Right.
Attention mechanisms let the model do the same with text, instantly zeroing in on the key parts.
So it's not going word by word like those RNNs. It sees the whole sentence.
Exactly. It figures out the most important parts immediately.
That's wild.
Yeah.
But wouldn't it lose track of the order of the words?
Ah, great question.
Like if it's not going in order, wouldn't the meaning get all jumbled up?
It uses these things called positional encodings.
Oh, positional encodings.
They tell the model where each word sits in the sentence, like little timestamps.
So it knows the sequence, even if it's not processing them one after another.
Exactly. It's like, those timestamps on security camera footage?
Got it.
You can jump around, but you always know when things happen.
So the transformer uses attention to grasp the meaning, multi-head attention to look at it from different angles, and positional encoding to keep it all straight. But okay, how does this actually translate to results? Because the paper claims some pretty big improvements.
Yeah, and they delivered
What do they actually see?
state-of-the-art performance on machine translation.
Wow.
Better accuracy and faster than anything before.
It's like they found a shortcut.
More like they found a completely new route.
So what made it so much faster?
Being able to process the whole sentence at once in parallel.
Ah, so it's not waiting around for each word.
Exactly.
This must have been a big deal for training these models.
Huge. It meant you could train much larger models on tons more data.
And since it doesn't have to go word by word, I guess it can handle much longer sentences.
Exactly. Things that would have tripped up those old RNNs.
Like going from a horse and buggy to a bullet train.
Perfect analogy. But there's one more thing.
Okay.
Interpretability.
What do you mean by interpretability?
We can actually see what the transformer is paying attention to.
Wait, really?
We get a peek into how the model is thinking.
That's incredible. It's not just a black box anymore.
Nope. And the paper actually includes some visuals of this.
Oh, yeah?
Take a look at figures 3, 4, and 5. You can actually see the attention at work.
So it highlights different parts of the sentence depending on what it's trying to do.
Exactly.
That's mind-blowing.
Figure 3 shows how it tracks those long-distance relationships between words, like we were talking about.
Okay.
And figure 4 shows how it figures out which words those pronouns refer to.
That's awesome. But hang on, this paper wasn't just about translation.
Right. Oh, no, not at all.
So is it more like transform everything?
Pretty much.
What else can it do?
Text summarization, question answering, even breaking down the grammar of a sentence.
Wow. It's like they found a fundamental building block for understanding language.
That's exactly what makes this paper such a huge deal.
It's not just a new model. It's a whole new way of thinking about how machines can process language.
And that new way of thinking, it's had a huge impact.
On everything.
From those translations you see online to those voice assistants we all talk to.
So it's not just theoretical, it's actually in our lives.
Every day.
Okay, so we've got the big picture.
Yeah.
Now I'm really curious about the detail.
Your nitty-gritty.
How does this thing actually work?
Let's dive in.
Great.
So the transformer, it actually follows a structure you might have heard of before.
Like what?
The encoder-decoder model.
Oh yeah, encoder-decoder. I've definitely come across that.
Yeah.
Remind me, how does that work again?
Think of it like a two-step process, right?
Okay.
So the encoder takes the input,
Which would be like a sentence.
exactly a sentence, and it turns it into this representation, this like concentrated meaning.
Okay.
And then the decoder takes that representation and uses it to generate the output.
So if we're talking translation, the encoder understands the source language,
Right.
and the decoder spits out the target language.
Exactly. And the cool thing about the transformer is that both of these, the encoder and decoder, are built with attention.
Oh, wow, so it's attention all the way down.
Attention all the way down.
I like that. So how do these attention mechanisms actually work within the encoder and decoder?
So both the encoder and decoder, they're made up of these 6 identical layers,
They kind of identify.
kind of stacked on top of each other.
Okay.
And each layer, it's got those multi-head attention mechanisms.
Right. We talked about those.
Yeah, and then this thing called a position-wise feed-forward network.
Hold on. Position-wise feed-forward network. What's that?
It's basically a neural network,
Okay.
but it processes each word's representation, like, individually.
Individually.
Yeah, kind of refining what the attention mechanisms did.
So it's like fine-tuning each word.
Exactly, making sure it understands each word perfectly, in the context of the whole sentence.
Okay, so each word gets its own little spotlight.
Yeah,
But wait, doesn't that contradict the whole idea of parallel processing?
good catch.
If it's doing each word one by one, wouldn't that slow things down?
This is where the transformer's really smart, right?
Okay.
Even though it processes each word individually in this step, it does it for all the words at the same time.
Oh, so it's still parallel.
Exactly. No waiting around.
That's clever.
Makes the whole thing super efficient.
Okay, so we've got these stacks of layers, attention, and feed-forward networks all working together.
Yep.
Now, the paper also mentions some specific techniques they use during training, like dropout and label smoothing.
Oh, yeah. Those are important.
What are those all about?
It's about making the model, more robust, preventing overfitting.
Overfitting, like when you cram for a test and just memorize the answer.
Exactly. You might ace that test, but you won't really understand the material.
Right, you can't apply it to anything new.
Exactly.
So how do dropout and label smoothing help with that?
Dropout's kind of cool.
Okay.
It randomly drops out some connections in the network during training.
Dropped out connections.
Yeah, so the model has to learn multiple ways to get to the right answer.
So it can't just rely on one trick.
Exactly. It's like studying using different textbooks.
So it develops a deeper understanding.
Exactly. More flexible.
And what about label smoothing?
That one makes the model a little less confident in its predictions.
Less confident. Why would you want that?
Sounds weird, right? But it actually helps it become more accurate in the long run.
So it's like saying, I'm pretty sure this is right, but I could be wrong.
Yeah. It keeps the model open to other possibilities.
More nuanced.
Exactly.
So it seems like every piece of the transformer, from the architecture to how they trained it,
Yeah.
was designed to overcome those limitations of the older models.
Yeah, push the boundary.
To really understand language better.
That's what makes this paper so important, right?
Yeah.
It wasn't just a small improvement. It was a total game changer.
A paradigm shift.
Exactly.
Okay, but all this theory is great, but how well does it actually work in the real world?
The results were amazing.
Like what do they see?
Way better accuracy on machine translation, faster training.
Faster training, that's huge.
Yeah, meant we could train much larger models on massive data set.
Like those huge language models we have today.
Exactly.
Yeah.
It all started here.
So they basically unlocked a new level of capability.
Crack the code.
So this isn't just some theoretical breakthrough. It's really changed things.
Yeah,
It's in the tech we use every day.
absolutely.
Okay, we talked a lot about translation.
Right?
Did you mention other applications?
Yeah.
Like text summarization, question answering.
Oh, yeah, those are really cool.
How does the transformer do those?
So summarization.
Okay.
The transformer's really good at grabbing the key points from a long document.
Oh, that's useful.
Super useful.
Like for news articles or research papers.
Exactly. It can condense it all down into a nice short summary.
So how does it do that?
It uses its attention mechanism
Okay.
to find those important sentences, the phrases, and just ignores the rest.
So it's like a super efficient reader.
Exactly.
And what about question answering?
So for question answering, we train it on huge amounts of text and kind.
Wow.
So it can answer a huge range of questions.
Okay.
And it can even be specialized for certain areas like medicine
Yeah.
or law, complex stuff.
So it's not just memorizing facts, it's actually understanding the question and finding the answer.
That's the key, right?
Yeah.
And it's not just retrieving information.
No.
It can generate answers in natural language.
Oh, wow. So it can have a conversation.
Exactly.
Perfect for those chatbots and virtual assistants, right?
Exactly.
It's amazing how this one model can do so much.
It's the power of language understanding.
Okay, so we've seen how it can break down sentences, find key points, answer questions.
Yeah.
But is there anything it can't do? Like, can it understand emotions?
That's a great
It
question.
seems like a pretty big leap.
It is, but, researchers are working on it.
Really?
The transformer's ability to understand relationships and context, it's showing some promise for things like sentiment analysis,
Sentiment analysis.
figuring out the emotional tone of something.
Like if a movie review is positive or negative.
Exactly.
Cool.
But it could even go beyond that, sadness, anger, joy, all the nuances.
Wow, so could this lead to AI that can actually understand how we feel?
Maybe. Imagine a virtual assistant that can offer support.
Or change how it talks to you based on your mood?
Exactly.
That would be a game changer.
It would.
It's like we're on the verge of machines understanding us on a whole new level.
It's exciting, but we got to be careful too.
What do you mean?
With great power comes great responsibility.
Right. We need to make sure this tech is used for good.
Exactly.
Okay, so we've talked about the big picture, how it works on a high level,
Yeah.
but I'm ready to get even deeper.
Let's do it.
Let's see what else this paper has to offer.
All right, so we've talked about the big picture of the transformer.
Encoders, decoders, attention mechanisms, all that good stuff.
Yeah, the whole shebang.
But there's one piece we haven't really dug into yet.
Oh, yeah.
Self-attention.
Self-attention. The heart of the transformer.
So how is self-attention different from that multi-head attention we talked about?
So remember, multi-head attention, it's looking at different parts of the input.
Right, to figure out the output.
Exactly. Self-attention, though, it's focused on the input itself.
Okay, so instead of looking at how the input relates to the output,
It's looking at how the input relates to itself.
it's like the model is analyzing its own thoughts.
Yeah. Figuring out how different words in the sentence connect to each other.
So it's building like a deeper understanding of the sentence itself.
Exactly. Like think about pronouns, right?
Okay.
Or those sentences where the meaning isn't clear right away.
Ambiguity.
Yeah, ambiguity. Self-attention helps the model sort all that out.
Can you give me an example?
Sure, imagine this sentence. The cat sat on the mat, which was blue.
Okay.
Self-attention would let the model link that which back to the mat.
So it knows we're talking about a blue mat.
Exactly. It's like the model is drawing lines between the words, showing the connections.
Creating a map of the sentence.
That's a great way to put it.
It's wild to think that a machine can do that.
I know, right? And it's a big reason why the transformer is so good at all these language tasks.
This whole idea of attention is mind-blowing.
It is.
It's like we're peeking into how humans understand language, you know?
Totally. We focus on certain words, make connections, and that's how we build meaning.
And the transformer does the same thing.
Exactly. It's mimicking that human way of thinking.
It's like they looked at the brain and said, let's build a model that works like that.
And it worked. This breakthrough, it's had a huge impact on AI. So many new ideas have sprung from it.
So we've gone pretty deep on this paper. We've covered a lot of ground.
A lot of ground.
What are the big things you want listeners to take away from all of this?
I think the biggest thing is the transformer, it's a whole new way of thinking about machine learning and language.
It's not just a tweak to the old methods, right?
No, it's a total shift. We've moved away from those old step-by-step models.
The RNNs.
Yeah, the RNNs. Now it's all about parallel processing and attention.
Like a whole new era.
Exactly. And you see the impact everywhere. Machine translation, chatbots, text summarization.
It's changed how we use language in the digital world.
Sure.
So the next time someone asks about Google Translate or how a chatbot can hold a conversation,
Yeah.
you can tell them all about the transformer.
And how it understands language.
I think it's safe to say that attention is all you need really lives up to its name.
Oh, yeah, it does.
This paper, it's not just a new model. It sparked a whole wave of innovation in AI.
And it's still going strong.
Who knows what's next?
That's the exciting part.
As research keeps moving forward, we'll probably see even more incredible applications of the transformer,
Oh, for sure.
pushing the limits of what's possible with language and technology.
It's going to be wild.
It really is an amazing time to be following AI.
The future is bright.
And the transformer, it's a shining example of what we can achieve, Human ingenuity and technology coming together.
I couldn't have said it better myself.
Well, it's been awesome diving deep into this paper with you.
Likewise. Always a pleasure.
And to all our listeners out there, keep exploring, keep learning, and stay curious. The world of AI is full of amazing things just waiting to be discovered. Until next time.